A brief comparison of 2D and 3D velocity probes. A short video featuring Dr. Kevin Linfield. This video is brought to you by Airflow Sciences Corporation for all your flow modeling and testing needs since 1975. If you spent any time trying to measure the flow in an industrial application, you're no doubt familiar with the S probe. This modification of the classic L-shaped pitot-static tube has been the standard of real-world flow measurements for decades. S probes are almost bulletproof, with a simple design that's easy to manufacture, easy to use, and easy to master. With all of these factors working in its favor, it's easy to see why people tend to overlook its very real limitations. One of the underlying assumptions for S probes is that the flow being measured is traveling perfectly axial in the duct. While there are certainly cases where this is a reasonable assumption, they tend to be the exception rather than the rule. In reality, most test ports are placed in close proximity to duct bends, fans, dampers, internal structural elements, or other items that can alter the direction of the gas flow. Even in areas where there's a nice long uninterrupted duct run, this axial flow assumption can fall apart, as anyone who has ever watched the swirling flow leaving a smokestack can attest to. Fortunately, for those who are interested in obtaining an accurate measurement of their air or gas flows, there are better tools available. 3D probes operate on the same basic principles as the S probe, but are well suited to measuring non-axial flows. 3D probes utilize 5 pressure ports arranged at different angles so that they can accurately measure all 3 components of velocity as opposed to just the axial portion measured by an S probe. These probes come in 2 different types, the prism probe and the spherical probe. So why haven't 3D probes completely replaced S probes? Well, they are definitely more challenging to manufacture, which translates to a greater cost. But the real reason is that they can be difficult to use. While the S probe requires only a single pressure as well as a temperature to be measured at each point, which can easily be done with a single handheld meter, the 3D probe requires 3 separate pressure measurements, plus an angle measurement and a temperature measurement. This results in a much more complicated setup to haul around a plant, as well as much greater opportunity for error when recording all that data. One way to simplify the data gathering is to use a computer system such as AEES 3D Probe Data Acquisition System, or 3D DAS. This device has been used to measure duct and stacked volumetric flows according to EPA Method 2F for over a decade. The heart of the system is a rugged industrial computer and a 16-channel, 16-bit data acquisition board. Data is collected and displayed in real time, allowing the operator to analyze results on the fly. It is fully compliant with EPA Methods 2, 2F, 2G, and 2H. For more information on velocity probes and how to use them, please visit www.airflowsciences.com. Thank you, and have a wonderful day.